the lesson this week is on the tides and how the tides are formed. Now, we live in Indiana, so knowing about the tides is probably pretty alien to you because we're not near a tide. We're 1,000 miles from an ocean. Has anybody ever been to the ocean?
Me.
Oh, good. So we have some prior experience. So the ocean, put your hands down. Thank you, ocean goers. You know, I always wondered, you know, the earth right here, this is going to be our model for the earth. And the first thing I want you to know about this model is that this is not to scale. I'm only doing this, showing this for demonstrations. If the sun was 6 feet in diameter, our earth would only be very small. But I can't draw that big, you know what I mean? So, not to scale. But, you know, I've always had a problem with it being called the earth because most of this planet is not the earth. It's covered with water. So I think we ought to call this planet Aqua. Aqua, or Agua, but not really. But for general purposes, we're going to call this the earth, okay? Now, so I have been in places by the ocean. I want you to know the distinction between waves that come in and go out. Waves are caused by wind or storms. Waves are not tides. Tides are when a large body of water comes in and goes out. How are tides formed? So, let's say we have the earth, and let's use this to represent the oceans. And so, if there was just the earth and the oceans, help me with this there, get this nice, it would be equal all around. The oceans would be an equal sphere, an aquasphere, if you will, around the earth. But the earth is not like this. We have a partner, and we call that the moon, right? Yes. So here's my rather strange lemon that we'll use as the moon. Yes, and now we know that the moon actually revolves and rotates. It rotates once as it revolves around the earth. It takes about 29 days or so for it to go through all of its 8 phases, right? So we're interested in the effect of the moon on the earth. And we're talking about something called what? Gravity. Gravity. So if the moon is here, it's going to pull on the earth, and the earth is going to pull on the moon. In fact, it's the earth's gravity. Without the earth's gravity, the moon would just go, ooh, keep going, probably towards the sun. So gravity is a two-way street. The moon pulls against the earth pulls against the moon. But here's what's very interesting. As this pulls, it pulls the oceans. And when it pulls the oceans that way, it also pulls on the earth and leaves a little bit of water out in space.
Evaporation?
No, not evaporation. When I say it leaves it, it's kind of interesting that as the earth goes, this changes. This pulls the water and pulls on the earth, leaving a little bit there. 6 hours later, basically, here, a little bit's there. That gets pulled in. 6 hours later, help me with that one. Pull it out and in. And this goes in. It's like a magnet. It's like a force. That's a pull force. Now, when this happens, we have different tides. I guess the best way to describe these tides, it's kind of strange, but okay, I'm laying in bed last night. My wife is reading her book, and I'm trying to sleep. She rolls over to turn on the light and pulls all the covers off of me. I'm having low tide, man. If the tide is like that cover, when she pulled it that way, it pulled off me. So I grabbed it and pulled it back. High tide. Everything was good. A little bit later, she goes to put her book, and so she has hold of the blanket, and she goes to put her book. It pulls the blanket off me. Again, low tide. This is kind of like this. When the moon pulling the blanket or the water, that'd be a high tide. This is a not so high tide, but the low, there's me with freezing in the bed. So that analogy, I hope that helps you understand that, right?
Yeah.
Okay, so tides, we would have 2 high tides, a really high tide, a not so high tide, a low tide, if that is what we only think we have. But there's something else that affects the tides. Anybody know? Yeah.
Sun.
The sun. And so I happen to have a model of the sun here. So the model of this sun, probably without the chromosphere, so we'll just, there's the core. We'll be studying more about the sun later. Here's my sun. There's its atmosphere. We'll take that off. Sorry, sun. All right, so the sun joins in. So here's the sun. And now we get some weird things going on, because now, even though the sun is 92 million miles away, or take, you know, because it's not a perfect circle, and the moon is 237,000 miles away, so this is close, that's far away, it still has gravity effects. It still has gravity effects. Now, not as strong as the moon, because the moon is closer. So here's what happens. When this tries to pull, this actually tries to pull also. So it changes the tides. And as this goes around, as the Earth rotates, we'll rotate the Earth, when it's at right angles to it, it really diminishes. Now it pulls this way and lessens the tide. See what I'm saying? So when this is at right angles, you're going to get different tides. There are 4 tides. So guess what would happen? So every 6 hours, maybe a little bit more than that, but every 6 hours, and every 6 hours, there is a different tide. So if you live somewhere by the ocean, if you're a fisherman or you want to take your boat out, you want to know when there's low tides and high tides. Question, Logan.
But what if the sun crosses over the moon and the moon crosses
Oh,
over the sun?
wow.
What tides would that make?
That's a great question. Go ahead and set that up. So Logan's going to set something up. He's going to add, the moon's always closest, but he's going to put the sun. What do you think's going to happen?
Like, most of the gravity doesn't come to both of them.
To both of them. And what is that called?
Now,
And that is called, right here is called a spring. That's a spring tide, and it's really big. Okay? Now, just the opposite, when, let's say this is over here and that's over there, we have what's called neap tides. When they're low, right? Neap tides. Now, I wish it was this simple. It's not. Science is never that simple, because the moon sometimes is higher in the sky, lower in the sky. The sun is higher in the sky, lower in the sky. And so that's why they're complicated. That's why we have tide charts. Yes?
So, if the moon was right here,
Yes?
it would be a solar eclipse. So
It would be a solar eclipse also. Very good.
So that will cause tides to
It-
go high.
When there's a full moon or a new moon, that makes the tides higher. What eclipse is this called? Lunar eclipse. So all of this is complicated, but you can measure them and write them. Now, one last thing. Sometimes you heard the word tidal wave, right?
yeah.
A tidal wave, even though it has the word tide in it, has nothing to do with the tides. Tidal waves come from earthquakes. Different. A tsunami. Okay, so I have asked a student to repeat the demonstration and share what she's learned. This is Sophie. Hi, Sophie.
Hi.
Speak up. So what would it be like if we had no moon?
There would be no tides, because it would be only able to pull one way and not.
So it would look like that, right?
Yeah.
So what happens when you add? Go ahead. Tell me what you're going to add first. You're going to add the moon first, right?
So add it right here.
Okay, that's what it's. Hey, you're in charge of the solar system. What do the tides look like now? You can ask someone to help you also.
The moon would pull the water this way, and then there'd be a little bit of water over there.
Okay. And so where are the high tides?
Right here.
And where else? Where's the high tide?
This
High
is the high tide, and this is
The high tide. Where are the low tides?
right here and here.
Very good. Then what happens?
And then you add the sun right here.
And how would that affect?
That's a lunar eclipse.
That is a lunar eclipse. So what about the tides?
They would,
Change a little bit?
yeah.
Okay. Show me what happens if the sun is here at right angles to the moon. What if the sun's right here at a right angle? So this is a right angle, like 90 degrees, right?
Yeah.
How are the tides going to be affected when the sun is at a 90-degree angle? Anybody want to help her? Oh, okay.
This way and this way?
Yeah, so they would not be high, they would be a little diminished. Anybody want to add anything to this? Go ahead.
If you put the moon right here and the sun over here, it would affect the tides to go even more stronger in the solar eclipse.
Solar eclipse, and what big tide would that be called?
Spring.
A spring tide. So spring tides are huge, right? And what if it's a small tide, a really small tide? It's called a
Neap
neap tide.